Hello dear students. So along with your module 4 wherein we have come across with your virtual memory management, okay. So and few more very important things we have come across to know with respect to virtual memory management, that can be demand paging, that can be page replacement algorithms, okay. Else it can be thrashing as a term, how your algorithm works, what do you mean by, and Balladay's anomaly, okay. So these all things we are aware now, okay. So followed up with that, your module 4 is a combination of another section into it, and that is your file system interface there. Okay, so that is file system is totally, it can be a combination of files, it can be directories. Okay, so how your operating system manages these respective files or else manages these respective directories, along with few basic concepts to be known regarding a file or else known regarding a directory. Then we are coming across with implementation of the same. Okay, it can be implementation of your file system or else implementation of your directory also. Okay, so these are all the things what are being covered, and respectively there are two chapters which are covering this particular section. If you are going with Galvin's 9th edition, so it is accordingly with chapter 11 and chapter 12, because if you go according to your syllabus, so it is with the Galvin chapter, with the Galvin 8th edition there. Okay, so there you can find these chapters in chapter 10 and 11 respectively. So just see it properly, or else and then itself the reference goes across. Else you can refer the video lectures there. Okay, so let's go across with the file system interface there. Okay, so in this chapter, you all are coming across with a few things to be known as file concept, okay, SS methods, disk and directory structure, file system mounting, file sharing, and protection. Okay, and in chapter 12, that's with your next section, we are coming across with the implementation of the file system there. Okay, so let us come across to know what do you mean by file firstly. Okay, a file is nothing but it consists of two distinct parts there. What are those? A collection of files, each storing the related data. Okay, and if at all I consider a directory structure or as a directory as a file, okay, so a directory always holds a content of a data. Okay, and then along with that it holds whether that particular content is an ordinary file or else it is an directory file or else it's an symbolic link file. There are different types of files there, so that's a one which has been managed according to a directory structure. It doesn't hold any data within it. Okay, ultimately the data holders are your file there. Okay, so these are all things which are being covered one by one. Let us come across. Okay, so firstly, let me come across to know that the when I'm speaking about the concept, okay, so you'll be coming to know that file concept happens to be an a file is a collection of related information that is recorded on second storage there. Okay, file is a sequence of, it can be bits, bytes, lines, or records. Okay, the meaning of which is defined by the file's creator. The one who is the creator of a file, so he is the person who is going to demand it. Okay, so usually we say that it is a contiguous logical address space. Okay, types are the data can be numeric form, character form, or else binary form, or else it can be in program itself. Okay, content is ultimately defined by, as I said, the file creator. Then there are many types of this: text file, source file, executable file. All of them are your regular file types. Okay. Next, let us come across with file attributes. File attributes are nothing but properties of a file, or else how a file is identified. Okay, a file is firstly identified by its name there. Okay, so name is nothing but the only information kept in human readable form. Okay, it is according to me, according to how do I feel comfortable, I will be naming a particular file there. Okay, secondly comes across as every file has an identifier. Identifier is a unique tag or a unique number that identifies the file within the system. Okay, we usually speak it in terms of inode number here. Okay, then comes type, the type of the file. So type of the file is usually when you go across with an UNIX as an operating system or something, so there you'll come across for a regular file type it is just an hyphen. For a directory file the type has been represented as D. Okay, for block device files or else character device files it is respectively B and C. Okay, so then it can be a symbolic link file. Okay, so we are getting across with a representation as L, or else it can be an S in some of the systems there. Okay, so these are all telling you regarding the type of that particular file. Okay, else even the type has been identified by its extensions also, dot doc, dot exe, like this. Okay, Then comes location. Where is that file being located? Okay, pointer to file location on that particular device. Then comes the size of that file. Okay, size is the current size of the file. Usually it is in terms of bytes, or sometimes it is measured in terms of words, or sometimes in terms of blocks of data. Okay. Then comes protection. Protection is a one which controls the reading of that particular file, or else writing onto that file, or else executing. These are nothing but I can just say them as permissions of a file. Okay. Then comes time, date, and user identification. User identification is nothing but the one who has created that particular file is been identified as user identification. Time and date are the one which are with the last SS time, last modification time. Okay, so those are all required for your protection of that particular data, that security. Okay, these are all your file attributes. That then there are various file operations which are being entitled. Okay, so what are those? Which is that can be creation of a file, that's a new file, like a write, read as an operation. You're repositioning within a file, that is when I open up a file for the next time. Okay, so it will be repositioned back to the very first very line there. Okay, so how does that happen? So repositioning within the file, delete as an operation, wherein I want to delete a particular file content there. Okay, truncate, wherein I want to merge some files there. Okay, that is truncation. Okay, else open, close. Open, usually it even acts as for a search of a file within a directory structure. Okay, so else even it can act across in some of the operating system for creation of a file also. Okay, so then comes close. Close is move the content of entry, okay, into memory directory structure on the disk. Okay, these are your file operations there. Okay, open file. Several pieces of data are needed to manage the open files there. Okay, so we usually say that every file, okay, every file is being identified across with a file pointer, okay, pointer to last read or write location, okay, per process that has file scene. Okay, then open file table, okay, that opens across with your open files there. Okay, then you have the counter for file open count there. Okay, counter of number of times a file is open, okay, to allow removal of data from open file table when last processes close it. Disk location of the file. Okay, so where is it being located? Cache of data, SS information there. SS writes per process and SS mode information is available. Okay, these are all things which you require when you're opening up a particular file there. Okay, even it has been advised that some systems provide even locking there, file lockings. Okay, even including your UNIX as operating system provides file locking there. Okay, there are again two different types of locks. One happens to be shared lock, one more is exclusive lock. Okay, you need not bother much. Okay, there are so many things which are being covered. Okay, so let us come across here with some file types. Okay, its usual extensions and functions. As you all are aware of it, executable has .exe, .com, .bin, or else it can be a none, which can be in hidden. Object file, okay, source code, batch, text, word processor, you all can guys see it. Okay, this is file type, this is a usual extension which is expected for this type of a file, and what's the functioning which it has there. Okay, so these are your file types there. Then let us come across with the file structure now. Okay, so what do you mean by file structure? File structure is study of different ways of storing files in secondary memory such that they can be easily accessed. Okay, so file types can be used to indicate the internal structure of the file there. Okay, usually you can just see that the structure that is understood by the operating system especially. Okay, then it can be UNIX treats all the files as sequence of bytes with no further with no consideration that there is an internal structure for the same. Okay, the operating system requires that an executable file have a specific structure. Okay, so that it can determine which happens to be the first instruction, which happens to be the second one. Okay, so the same thing. You can just come across some simple record structures are with lines, fixed length, variable length. Complex structures are formatted document, relocated load file. Okay, who decides the structure of a file? It's the operating system and the program. Okay, so now comes the SS methods. Now, how is a file is being how a file is being accessed now. The file information is accessed and read into the computer memory. Okay, how it has been accessed? It has been accessed in two ways. One happens to be sequential access and one more happens to be direct access. What do you mean by sequence? Here you can just see that the file is processed in order one record after the other. Okay, this mode you can call it as editors, compilers. Okay, usually access the files in this particular pattern there or else fashion. Okay, a sequential access, okay, so usually if I consider it onto the hardware section there, okay, it emulates the magnetic tape operation. Okay, and generally it supports the operations like read next, write next, okay, skip and record. Okay, so it is something like you are reading the next, write next, reset, no read after the last write. Okay, so then comes is direct access. What do you mean by this direct access from? Direct access is file is fixed length. Okay, logical records are considered. Read n, write n, position to n. Okay, read next, write next. You are going on reading it until this n is being reached. N happens to be the relative block number. Okay, so this is an SS method. One of the SS method, that's a direct SS. We can just come across. It's for sequential SS here. It's a beginning, it's a end, it's a current position. Okay, so when you are with the current position, you can use rewind as an option. You go back to the beginning. Okay, you read and write over here after the current position. Okay, you can just see here when it comes across with your direct SS, sequential SSs are reset. Reset is nothing but CP is equals to 0. Okay, then read next, that is read CP, read copy. CP is equals to CP plus 1. That's a counter. You are making it as plus 1. Go to the next line now. Write next. Write CP. CP is equals to CP plus 1. Okay. This is how the implementation for direct SS is done. Similarly, there are some other SS methods also. In that, one of the other SS method is index and relative files. You can just see here, this is an index file which has all the names here, logical record number. Okay. Every record number is having a relative file. Okay, that relative file is like, for an example here, Smith, John, Social Security. Okay, some kind of information is held with respect to your relative file. Okay, and let's come across with directory structure here. What do you mean by directory? As I said, directory is a structure which contains all the file names, okay, and the information about the files, like what's the location of it, what's the size of it, and all these things are held by a respective file there. Okay, that's a directory file. These are all your directories. Okay, these are your files which are tied up to each of the directories. Okay, both the directories and the files reside on the disk. Okay, let's come across with what's your disk structure. Okay, so what's your disk structure? This disk structure is usually can be divided into partitions now. Okay, so it can be partitions can be read protected against a failure. Disk or partition can be used raw, okay, without using the system, okay, without a file system or formatted with a file system. Partition are also known as mini disks, slice, and other things there. Okay, entity containing file system known as a volume. Each volume containing file system also tracks that file system's info in device directory or volume table of contents there. Okay, as well as general purpose file systems. There are many special purpose file systems frequently all within the same operating system. You can just see here, I have files here, sub files, okay, and these are my directories. Two directory I have, and these are my files. Okay, I say that this is my first partition, this is my second partition. Okay, for over on an entire disk. Okay, there is another example which you can consider the and higher storage capacity, and all the files are stored in only one respective file, and the partition here is a single partition there. I'm not making multiple partitions. So that this is with your directory structure there. Now comes what are the operations now. As you are performing operations on a file system, the similar operations are performed on a directory, but here it is quite little bit different there. You are searching for a file, that's an operation. You create a file in a directory, that is another operation. You delete a file, you list a directory, rename a file, okay, traverse the file system. All of them happens to be the operations performed on directory. Okay, So what's your directory organization now? It is logically to obtain two things in three things totally. Okay, one is efficiency, naming, and grouping. Okay, efficiency is nothing but locating a file quickly. Okay, first and foremost. Okay, second is naming, convenient to users. Okay, two users can have same number for different lines. Okay, then same file can have different several different names. Okay, this is called as naming convention. Then comes grouping, logical grouping of files by properties. Example, by all Java programs or by all games. Okay, fine. So these are with your directory organization there. Okay, there lies across with single level directory, wherein directory I have my files and these are the directories there. Every directory is been content across with each of the respective directory file. Okay, naming problem, grouping problem, these are all things which you are coming across in your further slides there. Two level says that this is my root. Okay, so after that I have a subdirectory. Okay, and within the subdirectory I have this file. Okay, so this happens to be my path. Okay, if I want to say the path of the second one over here, so it starts out from user one to your respective BO. Okay, so then it comes across with an your user. Okay, so similarly you have tree structured directories which are with multiple directories here. Okay, so as we say that tree structured directories are efficiently, it gives out for searching there. Grouping capability is quite good. Okay, and the current directory, you can find your present working directory very immediately with respect to your, because of this tree structured libraries or as directories. Okay, so your tree structured directories, okay, are usually being identified by absolute or relative path name. Okay, creating a new file is done in current directory. Okay, delete a file, that is usually rm, and give a file name. Okay, creating a respective new subdirectory is done in a current directory there. Mkdir, you give the directory name. Okay, if in current directory, you just send a mail to it. Okay, so mail, so deleting mail, it deletes the entire subtree routed by the mail there. So be very cautious when you are deleting. Okay, even most of the operating system does not allow you to delete an directory until and unless it is empty. Okay, then there comes an acyclic graph directories. Okay, acyclic graph directories are nothing but wherein I am having and pointing across with a left and a right nodes there. Okay, so like for example, when a same file needs to be accessed in more than one place in a directory. Okay, so at that time this acyclic graph directories come into focus. Okay, now like for example, directory, now if I consider, it can be your dict or as it can be spell. Okay, both of them are being required by. Okay, so two different subdirectories are, one is all, one more is words. Okay, so what ultimately it wants to say is, so this section or as this categorization is called out as, we call it across as a symbolic link, or else we call it across as a hard link there. As and how the file, the same file has been referred numeral times, we increase the link count there. Okay, so similarly with your Acyclic graph dictionary directories over here. Okay, two different names. Okay, dict deletes list, dangling pointer there. Okay, that is pointers, so that we can delete all the pointers. Variable size records a problem there. Okay, back pointers usually using a daisy chain organization. Entry hold count solution, then new directory, entry type. Okay, so new directory entry type is with the two things. One is link it, else resolve the name. Only two ways. Okay, so then comes across your general graph directory. You can just go through with this, wherein I have my main directories here. These are my subdirectories. So these subdirectories have my another subdirectory, and in that I have an respective file. Okay, so this is all regarding your general graph directory. Okay, so let's come across how do we guarantee that there are no cycles here. That is ultimately through your respective garbage collections. Okay, we say that there will be a no like for example, your file system mounting there. A file system must be mounted before it has been accessed. An unmounted file system is mounted to a mount point there. Okay, you can just see here. You go across here, okay, file, thread, okay, users, bill. Okay, so it is being accessed in a tree like a structure there. Okay, so this is one of the advantages. This is mount point. Okay, then we are coming across with file sharing there. Sharing may be done through a protection scheme. Okay, what is this protection scheme? It runs across on a single system or else multi-user. When it's a multi-user system, there are user IDs, group IDs, owner of a file, or else a group of a file. Okay, who are the allowers for the permissions to those respective files. Okay, file sharing system. Okay, or else we can have remote file systems there. Okay, uses networking to allow file system access between the systems. Okay, manually via program like you are coming across with the FTP. Okay, else automatically seamlessly just using distributed file systems. Okay, as it can be semi-automatically via the www. Okay, so there are many other file sharing even happens between the client and server. Okay, wherein NFS, CIFS becomes the most commonly used platforms there. Okay, so here comes, if all the file systems have the failure modes, okay, then corruption of directory structure, okay, or of a non-user data is called metadata. Okay, remote file systems can new failure modes due to network failure. Okay, recovery from failure, recovery recovery from a failure can involve state information about status of each remote request. Okay, stateless protocols such as NFS, okay, include all the information in each request. So with respect to protection for the SSS, we have different protections there. Okay, what are the protections? Ultimately, read, write, and execute. Okay, so these are the respective permissions there. I have of course set out in the class, if you remember, there are three categories of people. One is owner, group, and public, that is others. Okay, by default, these are the permissions which are lying. That is 7, 6, and 1. Okay, so 7, if at all I want to write it across in a 3-bit integer, okay, it goes accordingly as 111. Okay, so it is for 6 110, and for public SS or else for others it happens to be 001. Okay, wherever you find 111, so it means that read, write, execute accordingly. Okay, it asks the manager to create a group, say G, okay, and then add some users to the group for a particular file or subdirectory. Define an appropriate SS there. Okay, if you define an appropriate SS, these all things can be varied or else changed using some functions, some commands called out as ch mod or else chgrp, chown. Okay, there are various commands there. Okay, this is an sample example now. Okay, so it stands out. You can just come across with the first one. It is the intro.ps. Okay, which is an file to you. Okay, hyphen stands out for it's a regular file. RW stands out for read, write, and hyphen. Only read, write permission is given for the owner of that particular file. Okay, then read, write, and hyphen. Okay, that is no execution permission is given for others. Okay, then comes no writing permission also. Okay, R hyphen hyphen. R hyphen hyphen stands out for there's only read permission which is being allocated for the respective users. That is others. Okay, this is an sample UNIX directory listing. Okay, this completes your chapter number 11. Okay, in my next class we'll come across with your chapter number 12. Then okay, that's about your file system structure. Okay, which says how structure is being managed across for a file. Thank you.